Okay, during this video we're going to be focusing on spheres, and we're going to be talking about the surface area and volume of these spheres. I think these are two of the easier formulas to use, just they're a little bit more straightforward. So let's first talk about surface area. So surface area is going to be 4 pi r squared. R is of course your radius, so here's your formula for that. So surface area is 4 pi r squared. We'll talk about what's going to happen if we were to cut that in half and maybe just look at a hemisphere. We'll look at that on the next slide. Okay, this middle section here, this is just talking about different parts of these spheres. And so this just says a plane can intersect a sphere in a point or in a circle if the circle contains the center of the sphere. So if you look at this last sphere, the center is in the center of that sphere, and so this is considered to be a great circle. We're actually going to skip spherical geometry, talking about that since we're doing all this online stuff, but we would talk about great circles a lot more if we were talking about spherical geometry, but just you need to have just a general idea of what that is. Okay, the volume of a sphere is going to be 4/3 pi r cubed, and so that'll just be a pretty easy formula to use. Okay, so let's just talk real quickly about hemispheres. So this is if your sphere has been cut in half. You're going to see two different scenarios here. The first scenario is you have just this hemisphere. Okay, and if you think about the surface area of an entire sphere, it's 4 pi r squared. Okay, well, if we were to cut that in half, okay, the problem with that is that surface area is the area that's being shown, okay, the area on the surface. So if you look at the sphere up here, the surface area formula is getting everywhere on the outside of the sphere. Okay, well, when we now have cut it in half, not only do we have half of that, so we have all of this, but we now also have, if you were to flip this on its side, we have this circle that's being shown. And so that is in addition to the exposed area of the sphere. And so what we have to do if this is a hemisphere and we're talking about surface area, then we need to add in the area of that circle. So we need to add in pi r squared. So if I take 4 pi r squared and I divide it by 2, that's 2 pi r squared plus this pi r squared, and so that's really 3 pi r squared. Okay, that you will not see that in the formula chart. That's just like something that you have to know to do, because since that bottom part is exposed, you have to add in that circle. Okay, whereas if we, in the volume formula, it's just going to be the same, okay, because it's everything included inside. And so if we were to put water in there, if we were to get the entire volume of the entire sphere and just cut it in half, that would be your volume. Nothing tricky there. Okay, whereas when we look at this picture at the bottom, we have this cylinder on the bottom, and then we have this half of a sphere up top. We have this hemisphere. Okay, but the circle is not showing here. The circle is on top of that cylinder, and so we don't need to add that in. And so down here, whenever we would get the cylinder, but the hemisphere at the top, that would just be 4 pi r squared over 2, and nothing tricky about that. Alright, so here we go. We're just going to look at a lot of different problems, and if I see one that's kind of repeated, I won't work it, but if I think it's a little bit different, I'm going to. So if we look at number 1, determine the volume and surface areas for this sphere. Okay, this is just very straightforward. So surface area is going to be 4 pi r squared, okay, and our radius here is 18. Okay, and if I type all of that in, then I get 1,296 pi. So now, if we get our volume, it would be 4/3 pi r cubed, so 18 cubed. And if you do all of that, you get 7,776 pi. So that's about as straightforward as it gets with a sphere. Nothing tricky about that. Okay, number 2. Okay, so surface area. Okay, and I'm just going to skip this one because this one's straightforward also. So if you want to go back and check this, this is 144 pi and then 288 pi for the volume. Okay, that's just straightforward plugging it into the formula. Okay, we come down here, and the only thing that's being added in is that they're giving you the diameter. And so you need to say, okay, well then that means the radius is 10. And then it's just straightforward. You plug it in. So again, I'm just going to give y'all the answer to this because I think y'all are fully capable of plugging it straight into that formula. The volume ends up being a fraction, so I'm just going to go ahead and write it as 4,000 over 3 pi. The decimal for that was like 1,333.33 repeating. Okay, so now we come down here where we have to start doing a little bit extra work. And so the surface, so here it says a sphere with a volume of 4,000 over 3 pi. Okay, so we already know the volume. So that goes here, but we need to find the surface area. Well, to be able to find the surface area, then we need to know the radius. Okay, so we do not know that yet. And so what I'm going to do is I am going to set this equal to the volume formula. So I have the volume, which is 4,000 over 3 pi, and that equals 4/3 pi r cubed. Okay, since there's a pi on both sides, I can just cancel those out. I am going to go ahead and get rid of, well, this is the way you would have to do it. I'm going to get rid of this 4/3, so I'm going to multiply both sides by 3/4. Okay, and if you do that, you get 1,000 equals r cubed. Now, I have a calculator on my laptop, but I don't have one on my iPad, and that's where I'm doing this video. So you're going to have to kind of follow with me how to type this in the calculator. Some of you may just be able to figure out the cubed root of 1,000, but notice here, this is not the square root. This is going to be what's called the cubed root. Okay, so this is what it looks like. Okay, so we're trying to figure out what times itself 3 times is 1,000. So there is a button in the calculator for that. So if you hit math, and then you hit number 4, it's the cubed root, and then you just type in 1,000, and then you would see that the cubed root is 10. So that means 10 times 10 times 10 is 1,000. Okay, so that's our r. Now we can get our surface area. So surface area was 4 pi r squared. So that's 10 squared is 100 times 4 is 400. So our surface area is 400 pi. Okay, number 5. So here, this is kind of similar, except here they're giving you the surface area instead of the last one gave you volume. And so I am going to use the surface area formula here and set 12 pi equal to that. So 12 pi equals 4 pi r squared. Okay, and of course those pi's will cancel out. Then I'm going to divide by 4. So 3 equals r squared. And so the square root this time. So r is the square root of 3. Okay, of course they already gave us the surface area here. So all we need to find is the volume. So volume is going to equal 4/3 pi, and then r square root of 3 cubed. Okay, now here's where you got to think a little bit, because if you type in square root of 3 cubed in your calculator, it's going to give you a decimal. And we would like to keep this as neat and nice as possible. And so I'm going to write this out just so I can show you. So if this is square root of 3 cubed, that's like square root of 3 times square root of 3 times square root of 3. Okay, so square root of 3 times square root of 3, that's 3. And then you have square root of 3. Okay, so I'm just going to kind of go up here and finish this. So this is 4/3 pi times 3 root 3. So now I can just multiply that. So 4 times 3 is 12, divided by 3 is 4. So I have 4 root 3 pi. So again, you just can't do that part in your calculator if you want to keep it exact. Okay, this next one is giving you, notice what it says here, C equals 5 pi. So C, that is your circumference. And so circumference is 2 pi r. So I'm going to say 2 pi r equals 5 pi so that we can figure out what the radius is. Those pi's cancel out, and if you divide by 2, then r is 2.5. Okay, then you would just use that, plug that back into those formulas. And if I do that, let's see, surface area is 25 pi. Hold on, let me do that again in my calculator. Yep, that's right. Okay, I was just double checking that number. And then the volume is 125/6 pi. So if you want to work through those, great. Okay, and then we get to number 7. Number 7, I'm just going to set it up and then I'll give you the answers. So notice here the information they're giving you is the area of that circle. So it says the area of the great circle is 4 pi. Okay, and the area of a circle is pi r squared. So I would say pi r squared equals 4 pi. The pi's would cancel. So r would be 2 when you take the square root of that. Then you would just use that, plug it back in, and voila. Okay, number 8 is where we get to our first hemisphere. Okay, and notice here this hemisphere is not connected to anything. So if you think about everything that is exposed here, everything that is exposed is everything on the outside of this half circle, over this hemisphere, plus this bottom side, this circle. So this is one of those where we're going to have to add in the bottom part. So if you think back, we had to take 4 pi r squared, and we had to divide that by 2, plus we need to add in a pi r squared. So this comes out to be 3 pi r squared. So we can just use that and plug in r here. So we can do 3 pi 4 squared. 4 squared is 16 times 3 is 48. So it's 48 pi. And then the volume is very straightforward. Nothing tricky about it. Just plug the 4 in. And we do get a fraction here of 1/28/3 pi. Okay, we come over here to number 9, and I'm actually going to erase some of this so I have more room. So sorry if you still needed that. Just rewind. So we have this square prism. So if it's a square prism, that means this base down here is a square. So it's 10 by 10. I know that for sure. With a hemisphere hole. Okay, so square prism with a hemisphere hole. Okay, so if we want to get the surface area, we have 2 things that we have to get the surface area of here. Okay, so I'm going to first get the surface area of the prism. So surface area of a prism is perimeter of the base, so that'd be 10 times 4 is 40, times the height of the hemisphere. Okay, I just got a phone call and it kind of messed up the video, so I don't know where I stopped. I think I stopped talking about the surface area of the prism. So 40 times 13 plus 2 times the area of the base. The area of the base would be 100 because it's 10 times 10. So that would be plus 200. So if I add those up, that's 720. Okay, now I need to get the surface area of that hemisphere. So the surface area of the hemisphere, we need to, sorry, hold on a second. Okay, so on this one, I'm going to go ahead and just get what that hemisphere would be, and then we'll talk about this exposed area that's not there anymore. So I'm going to do 4 pi r squared. Okay, r here would be 5. So 5 squared is 25 times 4 is 100. So we would have 100 pi for the surface area. And then I just need to cut that in half because this is a hemisphere. So this hemisphere, without the circle that is exposed, would be 50 pi. But that piece was exposed, but it was taken away. So this is just a little tricky. We need to take away a circle. Okay, because it was there and it's not there anymore. And so if I take away pi r squared, that would be minus 25 pi. And so that would be 25 pi. 50 pi minus 25 pi would be 25 pi. So the surface area of this entire thing is 720 plus 25 pi. That's a tad tricky. Volume, I'm not going to go over the volume here. Volume, I think, is just a little bit simpler. Get the volume of the prism and subtract the volume of the hemisphere. Nothing too crazy there. Okay, number 10, we have this hemisphere in a cone. Okay, and again, I'll probably just do the surface area here because that seems to be the trickier part. So if I get surface area first of the, let's say the cone. Okay, so the cone is pi radius, which is 6, times L. Okay, remember L is your slant height or your lateral height. We do not have that. Okay, I'm just going to leave a blank for that right now. Okay, and now here's what's tricky about this. This cone, the second part of the surface area for a cone formula is pi r squared. So you can go ahead and write that. So you can write plus pi 6 squared. But what you have to realize is that that circle part of that cone, that's not being exposed. And so we actually don't even want to add that in because that part, you can't see that surface. So you can go ahead and write it, but then you would just have to take it away anyway. So I just go ahead and cross it out right there. Okay, and so now we just need to find that lateral height. And so if I do that, I just do Pythagorean theorem, and you end up getting 5 square root of 13 for the lateral. I'm just going to go ahead and write that. Okay, so the surface area of the cone is going to be 30 root 13 pi. Okay, so now we come down here to this hemisphere, and notice this is a hemisphere where the circle part is not exposed. Okay, and so this hemisphere, I will just do 4 pi r squared and I'll cut it in half. So that would be 36 times 4 divided by 2 is 72 pi. Okay, and so here our total surface area would be 72 pi plus 30 root 13 pi. And then the volume would be simple. Okay, again here, and I may just skip this one, I'll give y'all the answers in case you want them. Of course, I just dropped my paper. And you know what, I'll actually just talk y'all through this. So here we just have your cylinder, where you would take the circle away because it's not being exposed. And then on top you have your hemisphere. And so you just do 2 pi r squared for that. Okay, well that's pretty much it. I just put this slide up here just to make sure I remembered to tell y'all that we will not be doing spherical geometry. And so that is section 12.7, and we will not be doing it. We'll just save some time, and so I just wanted to make sure that I told y'all that.